We've sketched the algebraic solution down here, and we have this solution of the ellipse and the hyperbola, and we've put the coordinates of the intersections. And now we're going to solve this algebraically. So to solve this algebraically, we're going to do a like-for-like replacement. So in this case here, it looks like we can easily isolate the x squared in the blue equation, and then we're going to replace that in the red equation. So that's going to be the easiest way to do this problem. So we have y minus 3 squared minus 9, and that's going to be equal to x squared. Once we've done that, we can then replace the x squared in equation A. So we have 4, and then we have our x squared plus y squared equals 36. And the x squared can be replaced with the not y minus 3 all squared minus 9. Okay, so we've gotten rid of one of the variables. We're then going to solve for y. We're going to just expand out these brackets. So we're going to end up with 4. I'm just going to expand this out. This is going to be y squared minus 6y plus 9, and then minus 9 plus y squared equals 36. Since it's a quadratic, we're going to make it equal to 0. We're combining like terms first. We're going to get rid of some of these. So plus 9 minus 9 cancel out. And so we're going to be left with 4y squared minus 24y. And then plus y squared minus 36. And that's going to be equal to 0. We get 5y squared minus 24y minus 36 equals to 0. Okay, so we can solve this with a quadratic formula, but it looks like this is probably factorable. So we're going to just set up the factors here. So 5y squared, negative 36. This diagonal is equal to negative 180y squared. So we're looking at for two numbers that multiply to negative 180 and have a difference of 24. And that looks like it's going to be negative 30 and positive 6. Okay, so once we've established that, we can pull out our common factors. We have 5 here. We have a 6 here, so it's going to be 5y plus 6. Along here we get y, and we have a common negative 6 along that axis. So this is factorable, so we've now factored it, and we can rewrite the factors as 5y plus 6, y minus 6, and that's equal to 0. That makes y equal to negative 6 over 5. That's where negative 1.2 comes from here. Okay, so you can see our y equals negative 1.2. And then for the other y, we get y is equal to positive 6. We can see that on our graph as well. So once we've done that, we still want to solve for x. So we're going to plug in, I'm going to first solve for x using the positive 6. So putting it back into one of these equations, I'm going to put it back into equation A. So equation A is going to look like this: 4x squared plus y squared. Well, we solve for y as 6, and that's going to be equal to 36. Okay, so we end up with 4x squared plus 36 equals 36. Well, that's going to make our x equal to 0. So we get one solution is going to be at 0 and 6. Okay, so that's going to be one solution. I'm going to do the other solution in a different color here. So for the other solution, we're going to substitute y equals negative 6 over 5. So we get x squared plus negative 6 over 5 squared is equal to 36. So we end up with 4x squared plus 36 over 25 equals 36. Okay, solving for the x, we're going to divide both sides by, well, let's divide everything by 4. And so we get 9 over 25 is equal to 9. And then we end up with x squared is equal to, and so this works out to be 225 over 25. Okay, so we end up with 225 over 25, that's equal to 9. And then we're going to minus the 9 over 25. That gives us x squared equals 216 over 25. Okay, so when we simplify this, we end up with x equal to plus minus square root 216 over 5, and that's approximately equal to, as decimal value, our plus minus 2.94 approximately. So then the other solutions are going to be at positive 2.94 and 1.2, sorry, negative 1.2, and the other solution is going to be at negative 2.94 and negative 1.2. That was our negative 6 over 5 value. And again, we can see this showing up on our graph.